Okay, so in this video, we're trying to find the moment of inertia for a treadmill. So the treadmill has a bunch of different moving parts that we all have to take into account. So you see that we have the belt, we have a flywheel, we have the roller, and we have the DC motor, and then we also have a person standing on the treadmill that's going to contribute to all of that. So if we look at our picture, what we have here is we have a roller right here. We're also going to have another piece over here, but this one's just sliding, and so it's not rotating, so we only have one roller that contributes to the moment of inertia. We have a belt that goes around here. We have a flywheel that's a solid piece here. It goes on that roller. We're also going to have the motor that comes out this side, and it's going to have a rotor which is rotating, and then we have our little person, which we're just going to treat as a block. So we see that we have two solid pieces. Well, we have the flywheel and the motor, and then everything else is around. So let's look at the list of the moment of inertia. So what we see here is we have one point going at a fixed radius is mr squared. We also have a cylinder where all of its weight is mr squared, all at the same radius. So anything that applies its force at a radius of r is going to be mr squared, whether it's a shell or a point or whatever. So if I go back to here, we're going to see, let's start with the belt. So the belt is going to be the mass of the belt times r squared, where the r for all of these are going to be defined by the diameter. So you see the roller has a diameter of 6 inches. So that's the belt. We're going to have our roller. Times r squared. We're going to have our person. And it's also going to be at r squared. We're going to have our flywheel. Now the flywheel is solid, so since the flywheel is solid, we're going to treat that as a disk. So it's going to be 1/2 mr squared. And then we have our motor, which you see that gives us it directly, so we don't have to use an equation at all. So now we got to convert everything over to the right units. So we have all of these differences. So we have the belt has 2 pounds. The roller is 5 pounds. The person is 180 pounds. And the flywheel is 20 pounds. So we're going to have to convert all of these over. So we have 2 pounds is 0.907. The 5 pounds is 2.27. And the 180 pounds is 81.6. And the 20 pounds is 9.07. Okay, and then the 6 inches, which we want a radius, so we want 3 inches. So 3 inches is 0.076. And then we just have to plug all the... Okay, now we just have to add all of the pieces up. So let's start with the belt. So the belt is going to be 0.907 times my radius squared plus my roller plus my person plus my flywheel plus my motor. Okay, and then we just have to add all of these up, and we are done. And then our J total is equal to 0.52. And we are done.